Good morning, students. So sound chapter where we have left with the type of wave. First we have defined what is wave, then type of wave. There is mechanical and electromagnetic wave. So in this chapter we are dealing with the mechanical waves. Okay, so mechanical waves, the wave which can travel through the medium only. Medium means solid, liquid and gas. Okay, so these waves are of two types, transverse and longitudinal, and this chapter is about sound. So we are dealing here with only longitudinal waves. So you just see here, because these notes are like, they are additional notes. So if you want, then I will explain it later after the chapter will finish. Then I will explain it, because this is about the basics of wave. Okay, so the next topic is mechanical wave. So they are the mechanical wave by like vibration of the matter. So vibration can be up and down or back and forth. So two type of the vibration is there. Vibration means movement of the particle. Okay, so it can be transverse or longitudinal. So longitudinal is R waves, means it is like parallel. Okay, so like you are attaching one spring. The spring is like this. So these are the two blocks. So you are attaching the spring to two sides of the you can say block. So when you will stretch it, or when you will, suppose this is the string, okay, spring. So if you will do like this, then what will happen? It will not go up and down, it will go back and forth. Back and forth means horizontally it will go, it will not go vertically. So this horizontal movement is known as the parallel movement. Okay, it is parallel movement because wave is also moving like this and the particle will also move like this. So that is the sound wave. You can see, you will understand by this. You will understand by this. You can see here, this is the sound wave. Okay, and this is the light wave. So light wave, exactly, it will in the light wave, like this is the medium. So in the medium, the particle will move up and down, but the wave is always moving in this direction. Here also wave is moving in this direction, and particle is also moving in this direction. So when the particle is also moving the same direction as the wave, this is known as longitudinal wave. So this is the longitudinal wave, you can see. So both are parallel to the direction. Okay, so where you have to like connect this whole thing, you have to connect this whole thing with the electron model. Okay, atom model, sorry. So atom model we have understood by Thomson model, then the Rutherford model, then the Bohr model. So Bohr model is the most accepted one. But after the Bohr model, which model came? The de Broglie wave mechanical model. So in the wave mechanical model, what is given there? You can see here. This is not in this chapter, but the basic concept of this chapter is in this. So when you see the electron now, we have seen the like arrangement of the electron in the shells. Okay, so if you will see in sodium, so you have to understand the atomic number, atomic mass. So if you will see the sodium, it is 11. Okay, so means atomic number, then 281 you will see atomic number. So atomic number we use to create the position of the electron. So two electrons are, if you will see, this is the sodium, so two electron will come here. Okay, but you don't know what is the position. We are drawing it here, but this is the full area is there. You can see this area, this area. So these electron can be here, this electron can be here, 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 here. So the Bohr told you that two electrons are present in this orbit, but what is the exact position of that electron, he didn't say. Because what the scientists done, what the scientists have done, they have observed the electron and an atom, and inside the atom, when they are taking the pictures of the atom, of the electron inside the atom, they couldn't find that one electron at one place. Suppose they are taking it at 8:12, then after 8:30, so within a gap of 1 minute, they see the electron are changing their position, means different places. So this, to find out the exact position of the electron, the next model is given, that is wave mechanical model. So in the wave mechanical model, it is telling you, but we cannot find out where it can be present. Bohr said it is revolving, but wave mechanical model told that at what point, at what can be the position of the electron. Okay, so he gave us the formula. So it is like, it is not revolving in the circle, it is revolving like this. This is known as the wave mechanical model. Means some of the you can say some of the energy of electron, the electron energy is not present in like circle. electrons are always present in clouds. Okay, so you can see, okay, wait, I will show you what is the thing. See, as electrons are moving so fast that they cannot be at one place at one time. Okay, so they keep on changing their path. So one time they are moving in this, one time they are moving in this, one electron is moving in this, then second time you will see they are moving in this direction. So it is not always in this. So one time it is moving this, one time it is moving this, one time it is moving this. So electrons are, they keep on changing their positions. So this is the wave mechanical model. So what he said that around the nucleus the electron energy is present in the packets. Okay, electron, when they are moving, they are losing the energy. Okay, so that electron, suppose this is any atom, anything inside the world, they are having some energy inside that energy is known as potential energy, that you know, the rest energy. When they start moving, that energy will convert into kinetic energy. That kinetic energy, every particle's energy is present in a packet. Okay, that packet is known as photon. Okay, so what happened when they are having the lower energy electrons? Okay, suppose two electrons are there. Okay, so electron number 1, electron number 2. So what happened, they are present in E1. E1 means lower energy level. Then what happened when they are start moving? Okay, they start moving, so they are gaining the energy, okay, from the particular means suppose two electrons are there, they are hitting each other, so they are transferring their energy. So in this way what happened, this electron will become higher in energy, this electron will become lower in energy. So suppose this is electron number 1, this is electron number 2, so this is E2. Okay, this is E1. E1 means lower energy level, E2 means higher energy level. Okay, so when they will gain the energy, they will come here, and when this will gain energy, they will come there. And even when they start moving, they lose energy, they will come, they will return back. So in total, if you are confused about it, I will repeat it again. Listen, electrons are not moving in circle. They are moving, they are having different locations, they are having different path. Okay, so their path is not exactly circular, their path is different. So when they are moving, when they are going from lower energy to higher energy and higher energy to lower, they are releasing some energy. Okay, in this when they are gaining some energy, and when they are returning, they are losing some energy. So when they will gain or lose energy, that energy will travel in this medium in the form of wave. Okay, that energy, when that energy will travel from this point to this point, what happens, this energy will move in this wave form, and that is wave. So basically what wave mechanical model told you, or the next atom model told you, that electron energy is always traveling in the form of wave. Okay, so when they are moving, they are not moving in circle, they are moving in different paths. That is the origin of wave. Okay, now see, you have to learn in this only the definitions and the example. Okay, so transverse example is EM wave or light. In this longitudinal, when both are in same direction, particle and wave, the example is sound wave. So you have to learn only the example and the definition and the example, simple. So we have to deal with sound wave. If you are if you want to know the basics of wave, I told you, okay, from where waves are coming, when the energy is traveling, no, so they are traveling in the form of the waves. Okay, some of the energies are traveling in the form of the wave. So you see how the sound, now this will come. Okay, this will come in the examination, how sound move means propagation. Okay, propagation or travel, they are the same words. Okay, so propagation, when they are moving, how it will move, they are, see, always keep into your mind and fit this, that particle will not move. In sound wave means longitudinal wave, sound wave means longitudinal means they are always moving in spring. Okay, just think this in your mind, that sound wave means longitudinal, sound, longitudinal, parallel. Okay, these three you have to learn: sound, longitudinal, and parallel. Okay, so they are longitudinal wave means they will move parallel. Okay, so when they are moving parallel, particles movement is back and forth. It is back and forth, it is not leaving its place. Keep that into your mind. Particle will transfer the energy. See, this is particle number 1, 2 and 3. They are always fixed in their position. They are just moving like this. They will not, this particle will not go here. Okay, it will only just move here and there, and it will go near to the, means 2 and 1, they are moving like this, and when they will touch, they will transfer the energy, and again it will come at rest. It means what, when you are speaking, you are losing, you are giving energy to particle number 1, it will become high energy, then it will start moving like this, and it will give the energy to 2, then 2 will start moving like this, and 3 will start moving like this. So energy is like transferring, this energy is moving. Energy is moving means wave is moving, but particle is not leaving its place. Particle is also moving, but particle will not leave its place. So that 1 mark question can come, whether particle will move its place in sound wave. No, they will only move back and forth. They will not leave its place. They will just slightly move back and forth and give the energy. In sound waves, wave will move, but wave or energy will move, but particle will not move. That is the end of the question. Now the next one, this was the propagation question. Next one is a production. Okay, how it will produce? By the vibration. First is production. Production means it will move, it will produce by vibration. When particle will gain more energy, they will start vibrating. Okay, up and down, and in the vibration, when they are moving up and down, they will lose the energy. One particle at rest, it will, you are speaking, okay, you are speaking, you will give the energy to this particle. What will happen? Its potential energy become kinetic energy. When kinetic energy will come, kinetic energy means motion energy, so it will start moving up and down, up and down, up and down, and in this process, when it is moving up and down, it will release the extra energy, and when it will release the extra energy, it will come at rest. This is the basics of wave. And this, when it will lose the energy, that energy will travel in this medium in the form of wave. Okay, so that is the thing. This is the production of sound. So you see, and how it is moving. See, in the you know the diagram of the wave. It is the diagram of wave. The upper one is known as crest, lower one is known as trough. Okay, but in this, this is like when it is moving in transverse wave. It is transverse wave. Okay, but longitudinal wave means this is the light wave. When the light wave is moving, this is the sound wave. How sound wave is moving? See, when they will release the energy, it will give the energy to the particle presented here. Then these particles will start moving back and forth, then they will give the energy to this. So in this way, what happened? This, somewhere you will see the particle will come closer, somewhere the particle will go like away from each other. So in this portion, when they are moving back and forth, this movement will create two type of the areas in the medium between the source of sound and the destination of sound. This is source of sound, this is destination of sound, and energy is flowing in between these two. So when energy will flow, like when the energy is sound, not light, it is sound energy which is flowing from point number B to point number C. So when it is flowing, it will form area of low and high energy. So low energy area is known as rarefaction, high energy area is known as compression. I am repeating again, these waves are pressure waves. Pressure waves means what? When you see when you are having more balls in your hand, you will feel pressure. When you are having less balls in your hand, you will feel it is lighter. Okay, so when the more balls is there, you will feel pressure. They are known as high pressure, and that is known as compression. It is compressing you. Okay, it is compressing you. And when you are having low balls or low weight, what will happen? You will feel less pressure and you will feel up. Okay, that is a rarefaction. So sound waves are moving in two pressure region. They are moving as CR means compression, rarefaction, compression, rarefaction. That's why it is known as pressure waves. Again, I am repeating, when source of sound and the destination of sound is there, and from it sound will start traveling. So sound particle will not move. Keep that into your mind. Particle will never move. Only energy is moving. So energy is moving. How it is moving? It is creating an area of high pressure and low pressure. Okay, high pressure area is known as compression, and low pressure area is known rarefaction. So near to the sound source it is CR, then CRC. In this way the wave will travel. That is the point. So that's why these are also known as pressure waves, sound waves. This question can also come. Next one is, okay, these are some points. What is the propagation, travel, they needs the medium, particle will never leave, and energy will move as sound waves, means CR. Okay, next is coming reflection of the sound. Okay, next is coming reflection of the sound. So you see the reflection of the sound. What is the reflection of the light? Same the reflection of the sound. Okay, so reflection means it will hit some surface and it will bounce back, because this is opaque medium. Opaque means it can't go into this to the other side. Okay, suppose if I'm keeping one pen here, you will like hit the light, so light will not go beyond this. Light will hit and come back. It cannot travel through the, it cannot like go inside this and come from this side. No, it will hit it and come back. Same way sound is also there. You can just learn that if like one auditorium is there, so when you are like speaking something, okay, you both are inside, and until and unless you are having a microphone, okay, mics are there, nobody who is present outside, like your homes are there, so whatever you are speaking inside your home, nobody in the next house can hear. Why? Because there is like sound cannot travel through the, like it cannot travel through the wall, so well, it will not travel through the wall, but light is coming inside. No, light is coming inside. Okay, that is a different, we will like discuss this later. So you can see in eco we will discuss this is, okay, simple thing here is what, when any ray or any energy will hit any surface and come back, it is known as reflection. Okay, and here reflection, it is known as bouncing back, and it is also, it is goes in same medium. See, this same medium means what, it is a different medium. This is solid medium, no, this air medium, okay, gas medium, so it is returning in the same gas medium. That's why it is known as same medium travel. Same medium travel after bouncing back is known as reflection. Okay, now what is echo? Echo is also reflection. So reflection of sound due to the reflection of repetition of the sound. When the, okay, this is the reflection, when it will repeat itself. Okay, suppose this is like one box, so it will hit once, then reflect, then again second, reflect, again second. This is not the echo. So when it will hit something and it is returning back, suppose you are standing here, okay, and this is a like a wall, so if you are speaking something, your sound energy will hit this wall and come back to you, and you can hear your sound again. This is known as echo. So due to reflection of the sound, there create repetition of the sound. You can hear your voice again. You can like understand this phenomena if you are living near like mountainous region. So your sound will hit one like cliff or one hill and then returning back to you, and you are hearing it as echo. So reflection is bouncing back. Due to bouncing back, you can see repetition of the sound. Now there is reverberation. What is reverberation? Reverberation means multiple reflection of the sound. Some surfaces. Now see, both are multiple reflection. Now what is the difference between echo and reverberation? See, it is single reflection. Okay, when only one time reflection is coming. Okay, so hit coming back, this is echo. If more time reflection is there, it is not reverberation. Simple. Now second thing is that distance between the source and surface is more. For example, you can see I have given you the example of if the people who are living in the mountainous area, so when they are like moving, so what happen, they are moving in the like they are having this staircase roads. Okay, so when they are like speaking something, when they are standing on a hill and another hill is there in front of them, so when they are speaking something, what will happen, that sound will hit that hill and coming back to you. This is known as echo. Single time, simple thing is single time hitting back, here is echo. Reverberation means many time reflecting back. It is not reverberation.